Morning, everyone. First, thank Professor Shah for the kind invitation. So as Professor Shah mentioned, currently I'm in Singapore. Today I would like to introduce a relatively new research topic in multimedia area. But before I start it, I would like to first give a brief introduction on the major research topics in my group. Because I graduated from the mathematical department, so my group, the research is founded on this kind of machine learning techniques. For example, this one, actually, most of my highly cited paper are in this area. And recently, I also spent a lot of time to focus on this kind of large-scale computing series because, if you expect to process videos or multimedia data, mostly it will be in large scale. And like Professor Shah, we know that deep learning currently is so hot, right? So we just started this direction recently. And then finally on machine learning, I use machine learning techniques to solve the problems in computer vision and multimedia. Previously, I saw that this computer vision and multimedia are in parallel, but finally, I noticed that actually the multimedia is founded on computer vision and machine learning. So for computer vision, I study 3 layers. One layer is on face. Currently, we focus on this kind of occluded face detection, and also particularly focus on the age-related topic. For example, age estimation, cross-age face recognition, and cross-age synthesis. And the second layer is objects. So means we focus on the 3 major tasks in Pascal VOC. And actually, in the past 3 years, we are the winner for classification from 2010 to 2012. And we are the winner of the object segmentation in 2012. And the third layer is object interaction. We focus on the activity and the events in videos. So Professor Shah definitely is a pioneer in this direction. So I do not plan to introduce more here. So founded on computer vision and machine learning, I also started some research, some practical problems in multimedia area. Particularly, I focus on 2 directions. So first one is fashion-related multimedia. So means I try to study, for example, your hairstyle, your makeup, your clothes, and other maybe wearings and carryings. And the second direction is the so-called assistive multimedia technologies. So we focus on 2 directions. The first direction is to assist amateur users. What's the meaning? So it means even I give you a very professional camera, so maybe a lot of users do not know how to capture very professional photos. So we expect to develop some this kind of embedded function in cameras to assist the amateur users to capture very professional photos. And the second direction is to assist the disabled. We focus on 2 types of people. So one is with hearing impairments, another is with vision impairments. So for example, one work in the SA Multimedia 2010, the best paper award, is that we try to align the subtitle and the video so that we can identify the speaker in the video and then put the subtitle just beside the speaker. And then we align the speech and the text such that to highlight the word which is being spoken. So in this way, the people with hearing impairments can better entertain this kind of video. But today, I would like to just focus on fashion recommendation. So what is fashion recommendation? Fashion recommendation actually aims to make the following story become reality. So it means in the future day, when you get up, of course it's for girls. And you don't know how to, for example, dress your hair. You don't know how to perform the makeup. And then this so-called magic mirror can tell you what hairstyle you should wear and what makeup you should dress. And also the second one is the magic closet. So can based on your calendar today and tell you what to dress today. And then based on this recommendation, you can select your hairstyle, your makeup, and your clothes, and then you can have a very good day. Yeah. So basically, the fashion recommendation means in the future day, when you get up, you will have a magic mirror. This magic mirror is linked with your smartphone and knows what you will do today, and then can recommend the hairstyle for you today, and the shoes to wear today, and the makeup, and also the clothes, and maybe other wearing and carryings. And then you can take these suggestions, and also you can see the visualization on your head and on your body and see the effect, the visual effect. So today I will focus on the three aspects: hairstyle, makeup, and clothing. So I will introduce two systems. The first one I call as Magic Closet. Actually, this is a paper in last year SM Multimedia. And the second one is the so-called system is called as Magic Experts. We have two stages. The first stage is I give you image, and then you can synthesize the makeup effect on the face based on the recommendation of the system. And the second one is even more. So means we expect to synthesize, to recommend the hairstyle, the makeup, and then synthesize on your head. And then you can immediately see the visual effect on your head. Yeah. So for the first one, the so-called Magic Closet. Actually, Magic Closet expects to implement two functions. The first one is that you can tell the system what you should do today. So for example, you say, I will go for a conference. And then, based on your photo you have, and also maybe some clothes photos in your computer, then the system will do the analysis and then recommend the suitable clothes for you to wear for this occasion. Yeah. So this is the first function. The second function is that maybe besides occasion, you can also tell the system, maybe for example, for the upper body clothes, I want to wear this piece. Right? Because maybe this piece was bought by your girlfriend or girlfriend, right? And I want to pair another piece such that these two together is suitable for the dating activity. Yeah. Okay. So here the key is that what are the criteria on how to dress well? So we carefully studied this problem and checked a lot of materials online. So finally we noticed that actually the first criteria is that you should wear properly. So means for different occasions, for example, wedding, right? Actually, you should maybe dress very formally, and sometimes the material may be silk or some popular ones. But if the occasion is not wedding but is funeral, then mostly maybe the color should be in dark, right? Yeah, it cannot be too colorful. Yeah. So this is the first criterion. The second criterion is that you should wear elegantly. So means the upper body clothes and the low body clothes should be paired well. So for example, some experts, I mean the dressing or beauty experts mention that if you have a color ring, and then the upper body clothes color and low body clothes color should be similar to each other or contrast to each other. So means in this color ring, the angle should be 0 angle or maybe 0 degree or maybe 180 degree, cannot be 90 degree. If 90 degree, mostly the pair of clothes will not so good, looks not so good. Yeah. So this is a relatively new topic, so we do not have the database available in the research area, right? So first we collect the database and with about 40,000 clothes. And for each clothes, we use the users. Actually, it's not just a mechanical Turk. We recruited the undergraduate students to annotate which occasion is suitable for these clothes. Yeah. And this is the occasion wear. The second thing is that actually, when we mention the criteria for how to dress properly, actually, we noticed that we cannot use a low-level feature to describe this kind of property, right? We must use the mid-level attributes to express this kind of criteria. For example, you say the upper body, low body should be in color ring, right? The color should be similar or dissimilar. And also when you say you will go for wedding, right? Actually, you should draw formally, right? So in this case, low-level feature is not enough. You need to use mid-level attributes. So we define two sets of attributes. The first is category attributes. And the second is the details, including the color, pattern, material, and the collar style, for example, is a V style, round style, and the sleeve, for example, is a long sleeve, short sleeve, or maybe sleeveless, right? And also the low body bearing length. And then, in total, we have 6 types of this kind of detailed attributes. And here are some visualization of this kind of different attributes and the corresponding values for the attribute. Yeah. Of course, we have the high level, this kind of occasion, mid-level attributes. We need a foundation, right? So the foundation is features. So fortunately, we notice that the photos from this kind of fashion websites, online shops, right? The models will be well posed. So means the current computer vision algorithm for pose estimation can work quite well. Yeah, mostly. So we train a upper body detector and one low body detector. So means for upper body we have 20 patches and the low body we have 10 patches. And then for each this patch we extract 4 types of features, including HOG, LBP, color histogram, and skin features. And then you have the fundamental representation. So finally, you have the low-level feature, mid-level attributes, and high-level occasions. So the task is, when you have this high-level occasion, and what kind of low-level features should be recommended, right, for this occasion. Yeah. So we notice that actually there's latent SVM is a very good model to describe this kind of property. So basically, to rank the suitability of one closest to one occasion, actually we need to define a so-called score function or potential function. And here is the relationship, the feature extracted from the low-level feature, upper body attributes and low body attributes and occasion. Yeah. So here we take the attributes as a latent variable. So means given an occasion, we want to select and the one closest, we want to select the attributes which are with the largest score as the final score for this closest for a given occasion. So furthermore, we decompose this object function into 4 items. The first one describes the relationship between the features and the occasion. So this is continuous, this is discrete. And the second one describes the low-level features to attributes. And the third one describes the attributes to occasion. So these 3 items actually describe how to wear properly. So means for this occasion, what kind of clothes should be wear. And the first item describes how to wear elegantly. So means how the upper body and the low body should be paired together. Yeah. So for the first 2, actually related with features, so means for this item, for each part, we use pre-trained multi-class SVM to get the initial score and then to learn the weight. But for this part, third item, the first item, actually the discrete. So means the initial features actually will be the co-occurrence statistics between the attributes and attributes occasion or attribute and attribute. And then the task is to learn the weights, right? The weight of the W. And such that if you have set of training sample Xn and On, so means the closest and corresponding occasion, right? So we expect the ground truth occasion will have larger confidence or score than if you change the occasion to another one. So this is the traditional latent SVM. So I will not induce too much here. So finally, after you obtain this parameter, then you can do many things. The first thing is that actually you can, based on the closest and the occasion, you can estimate attributes. Yeah. The second thing is that the first target, right, is the closing suggestion. So it means when you are given an occasion, actually for each closest in the corpus or database, you will estimate the score based on the attributes with the maximum score. And then you select, based on the score, you can rank all the closest in the database to measure the suitability of these closest for certain occasion, for example, for wedding, for shopping. Yeah. And the third function is that actually you can perform this kind of closing pairing. What do you mean? So it means maybe sometimes our body closest is fixed, right? You want to recommend the low body closest, the features. And then for each low body, you combine with our body, you get origin X, and then use this function and you select the attributes for up body and low body with the maximum output, and then you can get a score. So means in this case, if up body closures is fixed, then you can rank all the low body closures and then obtain the final ranking list of the closures, and then you can return the highly scored closures to the user for this occasion, and to pair the up body closures. Yeah.
So how many, like you have lots of traces, right, in your database, that you have many traces, and from those you have computed these features and all those things. And given that database, then you can say, well, this upper body cloth and lower body cloth is good for this attribute. Is that right? I mean, so how many traces you have?
So currently the database size is 40,000.
40,000.
Yeah. So actually, as I mentioned to some of our students yesterday, so actually for this kind of paper, for each paper, you need to use about maybe 2,000 to 3,000 Singapore dollar to annotate the data. Otherwise, you cannot finish the project. Yeah.
So in this one, you are not looking into like different designers, like different designers have different style of these clothes. Like you can have Armani, or you can have Polo.
Yeah. So actually, we expect that these attributes can describe the designer styles of different designers. Yeah. Okay. So because we will learn the parameters, right? So let's visualize the parameters on how to wear properly and how to wear elegantly. How to properly so means for one occasion what kind of attributes will be suitable, right? So for example, for wedding, you will notice that the top three most related attributes will be silk, and what? Sorry. Sleeveless, dress, and silk, right? I think this is quite consistent with the common sense. And if you select the funeral, you will notice that bright color and the plain will be the two strongest attributes related with the funeral. Yeah, this is also very consistent with the common sense, right?
So in the previous one, what does dresses mean? Are that all everything about dress?
Dress so means is for upper body and lower body together. Whole thing. Yeah. And the wear elegantly so means how the upper body and lower body should be paired together. So first we look at the length part. So for example, for the upper body is a long sleeve, short sleeve, and a sleeveless. And the lower body, the length is long, normal, or short. So we notice that actually the strength between the long sleeve and the long lower body wearing, the relation is quite strong. I think this is also consistent with the common sense, right? So if you wear upper body is a long sleeve, but you wear a pant for low body, right? This looks quite strange, right? It's not so normal, yeah. And the second thing is for the style. For example, if you look at this, if the upper body is fashion hoodies, and we notice that the one with the strongest relation is the pants, right? This is, I think, is American style, right? Yeah, for young people, yeah. Okay.
So those were the rules your system came up with, or this is
automatically manned? Yeah. From this not half of the data, maybe about 30,000 clothes. Yeah. Of course, when we download the clothes from the fashion blogs and online shops, actually we selected those ones, for example, favored by the users. Yeah.
So these are actually the W's, the values.
Yeah, the W. Yeah. Okay. So actually, for fashion analysis, the most difficult part is that how to evaluate. This is quite difficult. Yeah. So because as I just mentioned, for the first talk, the clothing suggestion, right? So actually, we will provide the ranking list of all the clothes in the database, right? So finally, we consider this problem as a retrieval problem. So we use this popular NDCG as the measurement. Yeah. So we also implemented two baselines. So first one is from features to occasion, so directly train the SVM. And the second one is we first train the mapping from the features to attributes, and then train the mapping from the attributes to occasion. And then you can get a ranking list for all the clothes, right? Okay, so we have two sets of experiments. The first one is for suggestion. The second one is for pairing. Yeah. So here are the results for the suggestion. So you can see that it seems the performance for the first one, the feature to occasion directory is better than feature to attributes and then to occasion. So one explanation for this is that maybe the number of attributes defined here is too small because we only have 6 tabs, right? For the details. But in total, actually, the number is small. So maybe for this stage, some information has been lost. But actually, from the magic closet, the performance is much better. Yeah. So here are some visualization example results. So we randomly select a set of these kind of clauses, yeah, from the database. And then if you say that I want to go for conference, and then these are the top ranked clauses for this occasion. And
But
then
people don't wear this kind of clothes in conference, right? This is have you seen anybody in CVPR wearing that?
There's some conference, business conference.
yeah, this is
I saw
a
other
business conference. Yeah.
Technical conference is exception.
Okay.
Yeah.
Yeah.
Okay. So actually, these are the results for some other occasions. For example, for funeral, and for sports, and for wedding. Yeah. Of course.
Your database seems to be pretty West-oriented. That's all I can say. I'm sure like other
And
cultures are totally different.
And also summer-oriented.
Yeah, I guess it depends on the,
Yeah.
your database, right?
Yeah.
Obviously.
Because this one can also be, for example, from your own albums. Yeah. Not necessary to be like this. Yeah.
It totally makes sense. So
Yeah.
you're targeting American market. That's all I can see.
So
Okay.
one thing I have in the previous slide, go back to the
Okay.
back one more. So in this one, you had this thing that you just use features and do the SVM to predict occasion. Is that what you're saying? The first the green one.
Yeah.
So and then the red one is the features.
To
and then you
attributes.
have attributes like a mid-level kind
Yeah.
of thing.
Yeah.
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 And then do the occasion. Right?
Occasion. Yeah.
So it's interesting that always that's the case, that in the machine learning, this SVM thing, the feature most of the time perform just directly raw features perform well as compared to doing some intermediate, which is more meaningful semantic attributes. That's what we have noticed in most of the experiments, even like MED, the track vector.
Yeah. That's
So
right.
that's interesting.
Yeah,
Okay.
but actually for MED, the mid-level attributes are very effective because the number is very big, right? I think a few hundred, right?
Yeah, I mean it's
Yeah.
it's there.
Yeah.
You
But
can-
here maybe the main reason is that actually the attribute number is not so.
And how many do you have here?
For details, we have 6, but for this category we have more than 10. Yeah. But
Only 10 attributes.
No, I mean in total less than 20. Yeah.
20.
Yeah, it's not enough.
How many low-level features?
Low feature is very big. Yeah.
Yeah,
Yeah.
that's what I'm saying. It would be interesting if you increase the number of attributes.
Yeah.
Now, ideally, you should say like the match, actually, the relative comparison should be, the gap should be smaller.
Smaller. And
Ideally,
even-
I don't know what is true, but
I think if you increase the attribute number, definitely finally this one will be better than this one. Yeah.
You think so?
Yeah.
but
Because
the number still, the number of feature attributes should ideally still be much fewer than the features. Right?
yeah, definitely.
So that's
but
the
this
whole-
number should be big enough. Yeah.
It's almost like a dimensionality
You can,
reduction.
yeah,
right?
you can
That's
consider
one way
like
to look
this.
at it.
Yeah. But you can also consider this is a 2-layer, for example, neural network. In the middle level, you have the supervision information. Yeah. But
Is
And what is the magic closet? Is
Yeah,
like
exactly.
combining all those, or what is?
no. Magic closet is the method I mentioned later SVM based. Yeah, it's what.
But
we-
I mean, I see. So those are just SVM.
Yeah, so this is from our algorithm. These are the
okay.
two baselines.
Okay,
Yeah.
that's good. Yeah, cool.
So are you going to explain like intuitively why the magical closet is much better than that, besides the details?
So basically, the magic closet, actually we mentioned, right, describe the people criteria on how to wear properly and how to wear elegantly. Yeah, because the magic closet latent SVM, including the relationship between the attribute and the occasion, attribute and the low-level feature. So this to describe how to wear properly. But how to wear elegantly means the relationship between the between the attributes. Yeah, yeah. But the feature to occasion, feature attribute to occasion actually did not explicitly express this kind of characteristics. Yeah.
So if you have like any like Bayesian model maybe to compare or something, like it looks like this could be like kind of Bayesian kind of model that you can try. I don't know. Yeah.
Yeah, definitely. Yeah, you're right. You're right. If you use some other model, right, to describe the relation, maybe the performance will be also okay. But sometimes you cannot well explain why you can achieve this kind of result. Yeah. So here the main purpose is to, like a human knowledge motivated model, to express this kind of closing recommendation and closing suggestion. Yeah. Okay, so this is for recommendation. So for suggestion, for pairing part, actually, we do in this way. So means you are given an occasion and given a reference clauses for low body, and then we will rank the R body clauses. Yeah. So for this one, for each clauses, we will ask users to rate the satisfaction level of this clauses to pair this one for this occasion. Yeah. So for this one, it seems okay, but if you change to this one, seems sometimes you may have some strange results, right? I think the main reason is that in the training data, maybe you do not have this kind of clauses. Yeah. Yeah. Okay, here are some other occasions and other this kind of reference image and the corresponding recommended top results. Yeah. Okay, so finally, we notice that for this task, right, the key component is how to accurately detect the human body and the parts, right? So, but we expect to have a really usable this kind of demo. So finally, we decided to use Kinect because Kinect can provide you this kind of skeleton, right? So it means you can extract this kind of parts features very efficiently. Yeah. So finally, we developed a demo in Multimedia 2012. Yeah. So here is the demo. So it means you can use the left hand select occasion, for example dating, and then right hand select the part to pair based on another part of your body clauses. And then you click your hands, you wait about maybe 3 to 5 seconds. But actually the latest version, we just need about maybe 1 second you can get the result. You can roughly put the clauses on your body. And then you can change to the low body.
So this gesture, she's doing what? Like she's selecting something?
So it means we return 8 results here. You can select one of them to put what we put on your body and see the what effect. Yeah, of course, this system is also workable for male. Notice, this is not for virtual fitting. The purpose is recommendation. Yeah. Virtual fitting, actually, a lot of graphics professors are working on this, right? They can solve this problem very well.
That's actually quite useful.
Okay, so this is a demo system we showed in last year. Actually, this is the best demo award of SM Multimedia 2012. Yeah, because a lot of professors tried this demo and
they found they should wear.
Paul tried this demo and returned a very big T-shirt. Yeah. So he's very happy. Yeah. Okay. Yeah, but definitely I did not say that we have already solved the problem. So we just say this is an important direction because still quite a lot of problem to solve. The whole system quite relies on this body detection and body detection and body parsing. But actually, state-of-the-art algorithm cannot generally solve the problem. Yeah. So actually, we still have quite a long way to go to solve this kind of problem. The second thing is that the attributes prediction sometimes are not so reliable. For example, if you say the material, the silk sometimes is very similar to cotton. Yeah. But more importantly, this is the comments from the demo. A lot of professors told me that, hey, Dr. Ye, Shuicheng, actually the closing is very personalized. Yeah, you cannot say that you just based on occasion you recommend the clothes, right? So currently, my students is working on this project and try to, when you recommend the clothes, try to include your personal profile, including your hairstyle, your features, and maybe your height and the width of the body, and all these factors taken into consideration, and then we have provided this kind of recommendation. Yeah.
So in this thing, are you like able to determine automatically that this cloth is silk or cotton or some other material, or that's not what you're doing? Based on these features and so on, are you able to do in your system?
Yes.
If I to give you a picture, then your system can tell me that she's wearing a silk.
Yes. So actually, this has been included in. Maybe I'll go back. Included here, but in the paper I have some results. Yeah, but basically the performance is just so-so. It's still not so good. Yeah. As I mentioned, we can provide the 3 functions. This function is what you just mentioned. Yeah. So we give a clothes occasion, and then I can estimate the attributes. Yeah.
So I mean this, the
Can
distinction of material.
Yeah,
that
include
itself
the material. Yeah.
Is an interesting problem and
Yeah.
a pretty old problem. So you're saying you're somehow solving that based on the training data.
Yes.
So,
Yeah. But this is it's not like just from the image feature to attributes. Actually, we also take the occasion into consideration. So means occasion, attributes together, we can infer the attributes.
No,
of the
what
clothes.
I'm saying, see let's forget about what you're doing. So the question is, say I give you pictures, and there are these, women are wearing cotton or silk or some other material. So your system will tell me that this is silk or this is
Yeah,
cotton.
yeah. But the performance is not so good.
Yeah, because
Yeah.
so right now the method is based on just training. You
Just
can
training, yeah,
training
yeah.
simple, and your features are same HOG.
Yeah, yeah, yeah. So maybe the feature we used is not so suitable for this kind of material
Yeah, because
prediction.
people are doing this. Another guy came here, Nishino Go,
Texture,
he gave a
yeah,
talk.
yeah,
So he was looking into these things. There's a whole work in the computer vision
Okay.
from the reflectance.
Okay.
geometry
Yeah.
and
Yeah.
so on.
So means maybe when we consider these attributes,
Texture,
material
yeah,
attributes, we should use some even more
Yeah,
advanced
that's right.
features. Yeah. Yeah. Thank you. Yeah.
So, quick question. For the demo, the piece of clothing that you're showing for the demo that person can choose, are they segmented manually? Like,
Oh, you mean the clothes? Oh, this is a very good question. Yeah. Yeah. So actually, well. Yeah, for this demo, actually we recommend the clothes from the online shops. The online shops actually the clothes will be, right, just a clothes with a white background. So it's quite easy to segment out the clothes. Yeah, yeah.
and the method figures out that the clothes in this shop are related to the ones from your training data?
In the training process, we use both the clothes from the online shops and the street photos. Yeah. But when we recommend the clothes to you, I just recommend the clothes from the online shops because in this way it's quite easy to put on your body. But if you expect to use the photo from the streets, actually it's quite difficult to segment out. Yeah. Yeah. Okay. So second one actually is a Multimedia 2013 paper. The result just came out 2-3 days ago in Amsterdam. Yeah. So fortunately, this paper has been accepted. Yeah. And this system tried to consider another story. So maybe you have a girlfriend, a friend, just a normal girlfriend. Yeah, she.
What's the
What's the difference?
The female friend, right? Yeah. So she does not have time to do makeup, right? But one day on the social network, you saw a very beautiful photo of her. Yeah. So maybe in this case, maybe the background story is that she is using the so-called beauty expert system. Yeah. So the beauty expert system can recommend the hairstyle or hair templates and recommend the foundation color on the face, lip gloss color, and the eyeshadow color, and eyeshadow templates. Yeah, and then the system can automatically synthesize the makeup effect and the hair on your head, and then you will see this kind of photo. Yeah. Okay. So this is actually this problem has been explored in graphics area, but that one is just for synthesize. For me, I expect to achieve the goal that not just produce the visual effect, I should know what kind of cosmetic atom can be used to produce this kind of visual effect, and also how to produce this kind of visual effect. Yeah, this is my goal. It's not like traditional makeup papers in SIGGRAPH. Yeah, actually you can see quite a few SIGGRAPH papers in this direction. So my students will study this problem. So the first problem question to answer is what make women look beautiful. Yeah. So we notice that the first factor is the hairstyle. The second is the foundation color and the foundation material. The third one is lipstick color. The first one actually is eyeshadow, including the color and the template and the shape. Yeah. So we call these factors as beauty attributes. Yeah. But the second thing is that actually the beautification similar to the clothing is quite personalized. So means, for example, if your face shape is different, eye shape is different, jaw shape is different, then the shape of makeup will be different. Yeah. So we call these factors as beauty-related attributes. Yeah. And then, based on these studies, we propose this kind of flow chart to achieve our goal. So, because this is quite difficult to collect the useful data. So finally, we collect about 1,500 the photos, beauty photos. And then we design the features related and also design the beauty-related attributes and the beauty attributes. Yeah. And then we notice that the lateness realm is not suitable here. Why? Because for these different attributes, you will have a lot of values. Then the inference process will be very time-consuming. Yeah. This is one aspect. The second aspect is that actually the lateness realm, to describe the latent variables, use this kind of fully connected graph, or maybe just a set of fully connected graph. So in this case, the learnability is not so good, and the inference will be quite time-consuming. Yeah. So to avoid this kind of issue, we propose a so-called supergraph, and use the supergraph to describe the relationship between the different attributes. I will give more details later. And then, based on this supergraph, when you have a testing phase without makeup and the hair has been bounded to the back, or maybe very short, and then the system will recommend this kind of color, the hair size, and also this kind of other beauty attributes. Then, based on this, you can do the hairstyle, hair synthesis, and makeup synthesis, and then you can photo like this. Yeah. Okay, so basically first, based on the study, we defined this set of beauty attributes, including attributes for hair and the attributes for this kind of makeup. Actually, we have 4 types. Yeah. And here are some visualization of this kind of beauty attributes. And these are some templates based on the attributes for the hair. And this one actually is quite difficult for eyeshadow templates. So for this one, for each photo in the training data, we ask the user to use the Photoshop to roughly segment out the eyeshadow. And then for each eyeshadow part, we normalize to the mean face, and then we do this kind of robust PCR to remove the noise. And then, based on the refined photo with this kind of k-means, and then use the mean center to represent the different templates. Then you can have this kind of representative templates for the eyeshadow. Yeah. And for this kind of hair color, eyeshadow color, and the foundation color, lips gloss color, we just do simple this kind of k-means and then obtain the templates. Yeah. As I just mentioned, so actually all these are directly linked with the cosmetic atom of products. So means when you have this kind of recommendation, you can directly recommend the cosmetic atom for you, and such that you know which atom to buy online. Yeah.
So how do you connect the Kenyan center to those real products?
You mean this or this?
I mean, those,
This because the foundation just color, or maybe a few colors. So means, for example, you have 3-dimension color, right? And then you clustering, so means you just get a RGB color. Yeah, so RGB color we're used to represent this. Yeah. But for this one, so means actually we represent eyeshadow template as a grid level image, and then you use the image features for clustering. Yeah. Okay, so we also define carefully designed a set of beauty-related attributes, including many different types. Actually, we refined quite many times because when we discuss with different people, actually, their recommendations are different. So finally, we have this set of beauty-related attributes, most related with the face, and also related with the area. Just below the face. Yeah. Okay, we also need this kind of low-level image features, yeah, including many different types. But of course, if you think some more features are useful, then you can add more features. Okay. What's the problem? Oh, go back. This one. Okay. So similarly to the first problem, we also have the low-level feature and the mid-level certain attributes and the high-level semantics we want to model. But I just mentioned later SVM is not suitable for this. So instead, we propose use the probability modeling to model this kind of conditional probability, given a face and what are the probability for the given beauty attributes and the beauty related attributes. Yeah. So to describe this, we notice that fully connected graph is not so good, right? Too complicated. But the tree structure actually is not suitable for this. Why? Because we notice that for one attribute, for example, eye shadow, it will linked with eye shape. We also linked with face shape. So it means you cannot say that you use a tree structure. Tree structure so means you will lose the connection with at least one factor. Yeah. So instead of using tree structure, we use so-called supergraph. Supergraph is an extension of graph. So basically, besides the basic nodes, so means the attributes, we have the so-called supervertex. And each supervertex will include a set of attributes. And the super edge will link the supervertexes. And also we can define the order of the supergraph. The order of the supergraph means the maximum number of basic nodes linked by one super edge. Yeah. So for example, this is our case. So it means we have the basic nodes as attributes. And we have the supervertex as a set of attributes. And the super edge will link them. Yeah. So finally, based on the supergraph, we can define the energy function. The first item describes the relationship between the feature and the supervertex. And the finally term describes the relationship between the two supervertex. But still the same. So based on the supergraph, you can also have the fully connected, right? But in this case, actually the learning process and the inference process will be quite challenging. So instead, we propose to use tree structure, the supergraph, but we use multiple supergraph because some researchers mentioned, some friends mentioned that the makeup or beauty recommendation is quite subjective. Yeah, different people may have different recommendations. So based on this, actually we try to use the multiple graphs to express the different favors of different people. And then we use the maximum spanning tree to obtain this. So basically, the process is like this. So it means you have a set of attributes. So first, we select a set of seed attributes. And then, based on the mutual information between the different attributes, we can cluster the attributes into the supervertex. And then, based on the mutual information between the sets of attributes, we can build up this kind of supergraph based on the maximum spanning tree. And then you get the supergraph. Yeah. Based on the supergraph, then you can obtain the, you can learn the parameters based on the training data. So this is quite trivial, right? Actually, you just need to minimize the regularized negative log likelihood And of course, you can impose different regulation on the parameters. But the optimization process is quite easy because this is quite conventional. Just you need to use the gradient method, you can obtain the parameters. Yeah. Then after you obtain the parameters, when you have image, right, you can infer the beauty attributes with the maximum posterior of the distribution. But because, as I mentioned, the supergraph, right, is in tree structure, so the inference process actually is quite fast based on this kind of dynamic programming, right? Okay, so here are some supergraphs we learn from the learning process. For example, if you look at the second one, we notice that eyeshadow shape and eye shape are linked with, for example, lip color and forehead. And this strength is the strongest one for all the connections. Yeah. And also you can have even more different this kind of experts. So finally, for each expert, you can do this kind of recommendation. Finally, you can use the majority to get the results. And also you can use different experts to have different recommendations. Yeah. So when you have a new image based on the supergraph, and then you can have this kind of recommendation for hairstyle and the makeup. Then based on these recommendations, so first you need to do the alignment of the template and the face based on the face alignment, right? And the eyeshadow template, you should also do the alignment, and then you can warp this shape template to the eye. And then you can do the upper blending to include all these recommendations into the origin face. So for example, this is the example process. So means first you do the skin smoothing and then put this kind of foundation color into the face. Then you get this one. And then you put eyeshadow and corresponding color, and then you can get this result. And then lipstick color, you get this result. And then the hair template, and then you get this result. Yeah. Okay, so this part, because of time, I will ignore. That is still the same, is considered this problem as a retrieve problem. So finally, the performance, the new model is much better than the lateness SVM, and of course better than the other baseline. Yeah. So, but we noticed that actually in industry, a lot of companies already launched this kind of online service for this kind of makeup synthesis and this kind of hairstyle synthesis. Yeah. But if you carefully check this, some maybe just provide hairstyle, or some just provide this kind of makeup. Yeah. And some actually you need a manual process, so it's not so convenient. And most of the systems are not so easy to use because it's not just click and get it, right? Yeah. And most of the systems actually the template number is too small, so it's quite limited. But the most important thing is that none of this kind of system has a function for recommendation, because the purpose of this work is to recommend. Yeah, it's not just a synthesis. Yeah. So, but basically the result from TAAZ.com actually is a company owned by Professor David Kriegman. Yeah. So actually the performance is quite good, but the only limitation is that without a recommendation. So here are some comparison between our system and some other online systems. Yeah. So, but I have to say actually the result from Professor David Kriegman's system is good, but because here we select some face are very spatial, so sometimes actually the result is not so good. Yeah. Okay, so here are some more results. Yeah, some maybe these are from different supergraphs. You can have different results. Actually, for Chinese students, you know this one. It's very famous, right? Yeah, and this is also star. Maybe some of the young.
So who was that?
That was a famous TV person.
Yeah,
TV. Yeah. It's really probably the most famous one in China.
So here are the results. The input face with just makeup and with a hairstyle, and here is
This
another
one I don't
one
know.
with a makeup and a hairstyle.
So somehow, I think the hairstyle is too exaggerated, right? Suppose, I mean, in the previous one, can you go to the previous one?
This
I
one.
mean, this testing of face is fine, you know.
It's right, yeah. We cannot guarantee all the results are perfect, right? But I can show some to you,
I see.
which you may feel comfortable. For example, this one, and this one, and this one. My students say this one is very good, but I feel this one is the best, right? This one is the best. Okay.
I'm curious, like at first, all the images on the left, are those original images or you did something to it?
Nothing.
Huh?
Just original.
Nothing, just original.
Yeah.
So definitely they need to improve, I think. I thought that you did something to the left pictures.
No.
If it's just the original one, definitely they should improve. But you notice that always like a hair is longer is better.
No.
I noticed the trend. You never. Yeah, this is always longer.
Oh, you mean longer than original?
Yeah, I mean exactly.
No.
What I mean, the hair is always longer is better.
No. This is a
The black sheet.
this is a limitation of current system
Okay.
because if the hair, for example, the size is bigger than the new one, so actually it's quite difficult to remove this area because you will have a blank area in the background, right?
I see.
Yeah.
So I saw that the color on the background is also changing, like there is
Changing
just a
up.
little bit.
This is because for the hair template you have alpha map, so it's not 1-0, it's alpha map. So it means when you merge it together, actually the alpha map will affect the area around the hair. So-
I mean, the hair color actually changes. I'm wondering how much effect because he's dressing in black, because that could affect the hair. When you consider which choice of the hairstyle,
So-
are you also considering the wear
No, actually we just to
the
this
dress.
to this area.
Oh, just to this
Yeah,
area.
not
Has
to-
nothing to do with
yeah,
the
no body,
color
yeah.
of the clothes.
Yeah.
Okay.
But that is the future direction. It's a whole body suggestion. Yeah.
So do you think the data set is kind of biased?
Sure.
Because
Definitely. Definitely.
You are
Yeah.
training on
Yeah.
some celebrity which are
Yeah.
kind of
Yeah. I mentioned more data, more annotation are required. So currently it's quite biased by this available data set. Yeah. Yeah.
But in a sense, it shouldn't be biased.
Definitely.
Because
be
fashion
biased,
is
yeah.
totally a
Subjective.
subjective, yeah,
Subjective,
exactly,
yeah.
subjective
Yeah,
thing.
yeah.
There's no color people.
the thing is the training data they are born to
Yeah.
predict, but those are normal people when you test. They may need different kind of makeup.
Yeah, actually, yeah, this is quite good. So actually, my students are thinking about to discuss some of these kind of local makeup shops, yeah. And then maybe you sign some this agreement, you can get some, for example, 1,000 these kind of pairs before makeup, after makeup photos, right, from these shops. And then maybe the results will be more normal and natural, yeah, because this is from celebrity to normal people, as you mentioned, right? Yeah, yeah, this is a limitation currently. Okay, so for future work, we still have many things to do. One is that currently we just consider makeup, but actually you can also do the shape beautification. So it means slightly change the face. You can still sense the identity of the person, but at the same time, you can make the face look more beautiful. Yeah, this has some work in SIGGRAPH before. And also another direction, the beauty shape, the body shape beautification. This is also possible. And the last one we are trying to explore is that currently we just try to learn this kind of supergraph, but actually the supergraph sometimes supergraph based on the tree structure. But recently a lot of studies show that the tree structure sometimes is quite limited. Sometimes you need to bring in the so-called latent variable. Then the tree structure will be more representative. Yeah, so currently one direction to extend this kind of current work is to consider latent variables in the tree structure construction process, and then the representative property capability of the model can be enhanced. Yeah. Okay, so that's all. Thank you very much.